Hello everyone, and welcome to today's webinar. My name is Stephen Dwyer, and on behalf of everyone here at Symon, it's my pleasure to welcome you to what's coming next in Hyper-V. Now, Symon's going to share with us a lot of great information, and some of you might have questions about. So if you have any questions at all during the course of the webinar, please feel free to enter them in the Q&A window, and we'll get to them at the very end. Now, everyone at Symon is very pleased that Symon Perriman has kindly agreed to present today's webinar for us. If you don't know Symon already, he's an author and a contributor to technical books, a Duke University graduate with degrees in both computer science and economics, a Microsoft employee since 2006, a world traveler, and most relevant for all of us today, a Hyper-V expert. So with that said, it's my pleasure to turn things over to Symon.
Thank you for the introduction, and thanks for having me on this webcast. As Stephen mentioned, I'm a senior technical evangelist with Microsoft, with my focus being on virtualization. And so this means I get to spend a lot of opportunities working with our customers, presenting to them, and getting their feedback from them to figure out what's going to be the best direction for our product. In this session, I'm happy to talk to you about some of the features and enhancements that are going to be coming with the next version of Hyper-V. In our next version, we've really tried to focus on the vision of a cloud platform across all of our Microsoft properties. We believe that this is a unique strength that Microsoft has, as we have top in enterprise technologies that live in the private cloud on your own data center, in the public cloud with Microsoft Azure, and we've also enabled our third-party hosters to take advantage of these same type of capabilities by running our own cloud services in their own data center. Now, this is great for the people that are running those IT resources, but we also wanted to provide a consistent experience for all of the consumers of those IT resources as well. Now, for the IT professionals that are here on the webcast, we want to provide that consistency through virtualization, meaning that you could create a Hyper-V virtual machine and you can manage it using the exact same set of tools, regardless of which of these clouds it's running on. So you can create your own virtual machine, run it in your data center, move it to a third-party service provider's data center, and even scale it up to Microsoft Azure based on your needs for that environment. But that consistency doesn't apply just to our virtualization and IT admins. For our database administrators, we provide that same consistency for our SQL servers running on-premise or up in the cloud. For our identity experts, we offer Active Directory up in Azure and in your own data center using single sign-on and federation between these different clouds. And for our application developers, we allow them to build the same application in .NET Framework and have it operate the exact same way regardless of what cloud it is running from. Now essentially, what this means is that everybody can build the right application at the right time without ultimately worrying about where this application is going to be running. And this is the unique strength of that Microsoft Cloud Platform because it's going to run the same way regardless of which cloud it is placed on. Now, Microsoft Azure has been running some of the world's largest services for quite a while now. In fact, Microsoft has been in the cloud game for almost 20 years when we first started to offer web-based internet mail. Now, over this time, we've been running 300 million mailboxes, 40 million live Xbox Live accounts, and a whole lot of other massively scalable enterprise services. And what we're doing is we're proving these technologies up in Microsoft Azure, and then we're productizing them. We're actually bringing them down into Windows Server and System Center, and then offering those to our customers. Now, what this means is that when you go get the next version of Windows Server or System Center, you're not really trying brand new technologies. You're actually trying these technologies that Microsoft ourselves has proven at large scale for several years. So you can get some type of level of guarantee and confidence that these really are enterprise ready. As we get feedback and make changes, we send this information back to Azure, back to Windows Server, and so we kind of view this as an ongoing customer feedback cycle, using our own technologies to enhance our own services that we then offer back to our customers. In the newest release of Windows Server, that's going to be coming out sometime during 2015, we've really tried to break down the logic and our learnings from virtualization and apply them also to storage and also to networking. what we've really realized is across the compute, the storage, and the networking, there's three consistent planes. This is our management plane that our end users use to actually operate and interact with the technologies. The control plane that essentially serves as the brain that does things such as operations and management and basically runs the system. And then the data plane, which is actually the particular virtualized machine, network, or storage. So we span this out, we've really tried to go and provide consistency across these three different layers, across compute, network, and storage throughout these planes. And you're going to see one of our big focus points being on using standardized APIs across the stack. This is going to provide a lot of opportunities for all of our customers and our partners to plug in and manage their resources the exact same way. We found that management in the past as being one of the challenges with Microsoft's technologies. So by starting to provide this level of consistency and standardization across our technologies, we're hoping that it's going to allow our end users to get a much more consistent and easier management experience. Beyond that, this is also designed to help our partners like Symon be able to plug in to the technologies that Microsoft is building so that they can be integrated into various management consoles so that you can use their technologies on the back end or manage through those technologies on the front end and have it just an end-to-end integrated system so it doesn't look and feel like different technologies and different companies. Let's take a look at our Hyper-V focus first, which is primarily built around our computing stack. Now, as we think about our management plane, we look at our actual provisioning and operation tasks, creating virtual machines, running them. As we look at the brains, the controller plane, we think about our failover cluster as kind of like that centralized management unit that provides scalability and distributed management across multiple Hyper-V hosts. And then for the actual data plane, this is where we run our virtual machines themselves. Now we're going to dive down and take a look at some of the newer capabilities coming in the next version of Hyper-V in a little more detail. First of all, we still continue to have the industry-leading size for our virtual machines, our clusters, and VMs per cluster, making sure that we can really support the largest enterprise applications. Microsoft has also proven that Hyper-V runs best for Microsoft workloads. So if you've got high-end SQL Server, Exchange, SharePoint, Link servers, we recommend using the Microsoft stack of technologies because our engineering teams work together to ensure that things operate as fast and as reliably as possible. We've additionally announced recent partnerships with SAP and Oracle, ensuring that they can run both in Hyper-V as well as in Microsoft Azure. And in fact, Hyper-V is the only virtualization platform that Oracle supports, except for their own. So if you are using either SQL or Oracle, definitely consider investing and staying with the Hyper-V path. We've also started to work a little more with our hardware manufacturers, taking advantage of things like offloading different types of memory tasks into the physical hardware. This in turn frees up free CPU cycles that can be used for actually running virtual machines. One of the good examples here is Remote Direct Memory Access, or RDMA offload. When virtual machines are performing certain tasks like live migration and passing large amounts of data through their network interface cards, we can actually do offloads of some of that memory management, which means there's less kernel processing, which means that live migrations can go faster. And you're going to see Microsoft has been invested in working with our hardware partners to really try to light up a lot of these new industry capabilities. We've increased our utilization, providing better density, and now the ability to not only hot add and hot remove your storage, but also hot add and remove static memory and network interface cards, which means that you can keep your virtual machines running longer as you go and change different types of configuration and virtualized hardware information for them. We've continued to improve availability using failover clustering as our primary high availability solution. And we support the industry's leading best guest clustering solution. Now, guest clustering is essentially having a failover cluster that runs entirely in the virtualized layer. So if you think that you have two virtual machines or more, each of them are running Windows Server, what we can actually do is create a failover cluster between those virtual machines. This means that the application that is running within the guest operating system, such as a virtualized SQL server, can be made highly available as well, so that we could detect if that service crashes. We could fail over that SQL server between nodes, and when we need to do regular maintenance, such as patching or updates within the guest operating system, we could do that with less downtime for the actual virtualized application. And Microsoft has no limitations on its guest clustering support. We continue to support 64-node guest clusters, support all of the features that you would expect, like live migration, RDMA, 64 virtual CPUs, a lot of capabilities that our competitors are unable to match with guest clustering. We also wanted to improve how easy it was to actually go and upgrade to the next version of Windows Server. And so what we've done is we have provided zero downtime upgrades to our virtualization fabric, to our failover clusters. Now what this means is we could take a 4-node cluster, we can evict one of the nodes from the cluster, do a clean installation so that it's running vNext, and then add that back into the existing cluster. We could do this in a staggered approach, like a rolling upgrade, and gradually we move all of the cluster nodes from the old version up to the new version. Now the key thing here is, as we're doing this upgrade to the physical servers, we could do live migration for the virtual machines that are running on top of them. So this means that we can move our VMs from the old host to the new host with zero downtime for those virtual machines and for those applications by supporting a mixed mode cluster. Now in the previous release of Windows Server, we supported a similar upgrade process, but it actually required creating 2 individual clusters. So you would have your old cluster, your 2012 cluster. You would then have your newer cluster, 2012 R2. And while it was possible to do a one-way live migration between them, you still needed to manage 2 separate clusters and actually create a brand new cluster name for the newer one. What's different with this update, this release, is we can now have all of these mixed modes existing within the same cluster. So no need to create and manage 2 separate clusters. We also have the ability to live migrate backwards. So if you move a VM forward, you don't like the changes, you can roll it back, again with no downtime for those virtual machines. Let's actually jump over to my demo now and take a quick preview of how this looks. I'm going to switch over to Failover Cluster Manager here, and I'm currently running Technical Preview 1, which was released in October 2014. What I've done here is I have a 3-node cluster. I've currently evicted my second node from the cluster, and I've installed the Technical Preview. I've updated it, and I'm actually managing it from this updated version right now. What we're going to be able to do here, which we haven't been able to do in the past, is go and add a node. We'll skip some information, and it will ask me to go and specify the node that I want to add to this 2012 R2 cluster. In this case, I've selected my local node. It's going to quickly verify that this can join the cluster by checking its name against Active Directory, making sure the appropriate features are installed. I can click Next. It asks me if I want to run any type of validation test to ensure that this entire solution will work. Now, in real world, I definitely need to do this. It's required for support, but for the sake of the demo, I'm just going to skip this for now. It's going to ask me to confirm the settings. Going to add this node to the existing cluster. I'll click Next, and now you can see in the background that we are going and making this new cluster node an existing member of the existing cluster. So here's a good example of how we're really able to take advantage of this and show these mixed mode environments. Switching back to the presentation, one of the other things that we wanted to ensure that we continue to support in addition to these mixed mode clusters is the ability to do cluster-aware updating. Cluster-aware updating was introduced in the 2012 release as a way to essentially automate the patching of your failover cluster. What we could do is select a cluster node, select a collection of patches, either through Microsoft Update or through Windows Server Upgrade services, and basically apply those patches to all of those nodes in the cluster in a structured, automated manner while maintaining high availability. So we pick the first node, we drain the VMs from it using live migration, patch it, make sure the patch is installed successfully and the node rejoin the cluster, take it out of maintenance, and then go and repeat that cycle through all of our cluster nodes. So just an example here of how we're trying to really simplify the day-to-day operations of Hyper-V cluster management. We also wanted to make some improvements around management through System Center. Now, System Center, specifically Virtual Machine Manager, is what we use as our centralized management solution when you start to scale up to have lots and lots of Hyper-V hosts. This console allows you to unify the management across lots of hosts, lots of different clusters, and then give you different types of batch management operations, things such as being able to do load balancing within a cluster, or being able to do bare metal deployments. Now, what we've really focused on with the next release, first of all, is making sure that we could deploy anything that you're going to need in that fabric. So that's deploying your Hyper-V hosts, deploying your clusters, and even deployed scale-out file servers. And we could do this all the way from bare metal, and when we actually start running virtual machines on it, we of course support Linux and Windows virtual machines. Now, a scale-out file server is going to be important if you have a virtualization fabric, which is using the SMB3 protocol to actually store your virtual machine's hard disks. Now, if you're someone that's familiar with VMware, this would be something similar to NFS. Now, what we've basically done to store that virtual hard disk on a cheap type of shared storage is we actually place it in a Windows file share, such as whack my share. So essentially that virtual hard disk is running in a Windows file share. This is what allows us to have distributed access from multiple Hyper-V hosts. What a scale-out file server does is it provides high availability to actually access that virtual hard disk. It provides high availability for that file share name and basically places that file share's client access point across multiple physical servers. So if my virtual machine needed to access its virtual hard disk by going to whack my share /vm1.vhd, what we're actually doing is providing high availability for whack my share by distributing that client access point across multiple cluster nodes. This gives you higher availability and resiliency for your VM's hard disks, and all of that can now be deployed and managed through System Center Virtual Machine Manager. VMM is also going to be able to manage upgrades. It also gives you some level of monitoring, but this is really where Cloud Cruiser is going to come into play. So Vision's Cloud Cruiser gives you much better insight, much better monitoring, and also some different types of predictability patterns, things around capacity planning, resource planning that aren't available with System Center. So stay tuned, and we're going to be discussing those a little later in this webcast. We also want to make sure that we can really integrate with the public cloud wherever possible. And one of the most common scenarios we see customers use this for is for protection, meaning that you can go back up your data, your Hyper-V host information, your applications, and your virtual machines all the way up to Microsoft Azure. So if you run out of local space or you want a disaster recovery site, you can now use Microsoft data centers for that. Finally, we wanted to continue to support heterogeneous virtualization management. So not only will we continue to support Hyper-V, we will continue to support VMware vSphere too. Now, some changes that we've made that are specific to Hyper-V in the next release are as follows. First of all, we've actually changed how virtual machines will be serviced. Now, what this means is the tenant, the person that's using that virtual machine themselves, they're going to now be given more ability to control when their VM gets patched. Now, what happened in the past was we often had our Hyper-V admins, our fabric administrators, also responsible for patching the VMs. But in many cases, they should not be given access to those VMs for different types of security or compliance reasons. So what we've done is we've basically broken that boundary. We've said that tenants should be managing their inside their guest operating systems, admins should be managing the fabric, and so we've enabled our tenants to have better control of what their VMs do. Now, the biggest thing here is when we go and upgrade our integration services. Now, the integration services within a Hyper-V virtual machine are basically the components that allow the VM to know that it's a VM. Things such as making sure that dynamic memory can be used, or virtualized CPUs, or allowing the host to go and shut it down or restart it. Now, what we've done here is, in the past, the host manager would have to go and apply those updates inside the VM, we're now going to be pushing down those updates to the integration services directly through Microsoft Update. So this means that when your tenant goes through their regular patching cycle and needs to power down and update their VM, they will now see the updates for the integration services as well through Microsoft Update, so they can go and install them at the same time, make sure that they stay current and compliant. The next enhancement we've made to VMs is the actual ability to upgrade the virtual machine version number. Now, many people don't really see this. What this version number is it's actually it's a version within the Hyper-V configuration file. And this version number basically says what features are enabled for it and what different types of hosts it can run on. Now, in the past, when you deployed a VM on the latest version, it would automatically take that latest version's number. Now, the challenge that we saw was that was not compatible with previous versions. So when customers were migrating, some would build a VM on the new version, yet it wouldn't be able to run on the older versions of Hyper-V. What we've done now is we've kept the version number at the current version with vNext. And it's a manual process for when you want to go and update that to make sure that it can use all the latest vNext features. This way, it's going to be able to be migrated across all different types of mixed mode clusters. The third enhancement we've made is to the VM's configuration file itself. Now, the configuration file in the past was a plain text file that had information such as the name of the VM, the amount of memory, the types of virtual networks it was using, etc. The challenge that we had in the past was that people would be manually editing that configuration file, and that wasn't supported. The reason why it wasn't supported is when that virtual machine moved, if the VM didn't update its configuration file itself, it wouldn't capture the most recent edits. So let's say you made some changes to the VM's configuration file on node 1. The VM then had a failover event move to node 2. None of those changes would have been applied when it's on node 2. And so rather than trying to continue educating people that this is not a supported mechanism, we've actually just added another layer of security around this by actually encrypting this file. This means that the way that you need to go and edit the VM is through one of the supported methods, which could be WMI, PowerShell, Hyper-V Manager, Failover Cluster Manager, or System Center Virtual Machine Manager. The fourth enhancement we have on our list is specifically around checkpoints. Now, I'm going to jump to my demo and actually show you what this feature is rather than just explaining it. It'll help you understand it a little better. So I'm going to now switch over to my demo again. I'm running the technical preview, and here I have several virtual machines on my Hyper-V host. I'm going to jump into the settings, and for the most part, this looks pretty similar from the previous version. The big thing that you're going to see different here is what we call checkpoints. Now, first of all, checkpoints are used right now supposedly only for development and test, but not production. Basically, what a checkpoint does is it copies all of that running in-state memory onto a disk. So let's say you have a 16 gigabyte VM. You're a developer, you're making some changes, and you basically want to take a capture of that VM before you make a change to make sure that the change was appropriate, it doesn't do anything bad. If the change was bad, the advantage of checkpoints is you can quickly roll back to a previous state by simply taking that memory data from the disk and pushing it back up into that virtual machine's memory. Now, the challenge that we had with this is when you take a checkpoint, we don't make sure that all of the data is captured consistently. So if you have pending I/O, if you have data in your file system that hasn't been flushed to the disk, if you have pending transactions, open connections, these can get lost. And when the data is restored, this data isn't necessarily restored with it. So essentially what we're doing with this latest release is we have now enabled what we call production checkpoints. We've moved away from what we had in the past that was a standard checkpoint. With this production checkpoint that's on by default, when we actually create the checkpoint, we now speak to our VSS writer. And VSS stands for Volume Shadow Copy Service. It's basically an agent that runs with different applications and ensures that when a snapshot or a backup is taken, all of the data is captured. So for example, if I'm going to take a backup of a SQL database within a VM, I would have a SQL VSS agent, and whenever I say take a backup or take a checkpoint, we speak to the agent, and the agent goes and prepares that VM. It goes and flushes out those pending transactions, makes sure that all of the data is written to the disk, and then it will take the checkpoint. This way, when we go and restore the checkpoint, we can ensure that all of the data is there, nothing's corrupt, and that we basically have a complete copy. So, biggest enhancement with this checkpoint information, we are now supporting production checkpoints, meaning that by default, when you create a checkpoint, we speak to the VSS agent, and we ensure that all of your data maintains its integrity. Finally, we've made some improvements around remote management for Hyper-V. Specifically through the Hyper-V console, we give you ways to make it easier to connect, easier to manage, and easier to copy data between your host and your virtual machines. Now, I mentioned this a little earlier, but something that we're continuing to improve on is managing Linux as a first-class citizen within our virtual machines. Now, we realize that lots of enterprise customers have Linux VMs, so we want those to behave just the same as a Windows VM would. So we're making sure that we're included VSS support. You could support VMs the same size. We can do backup. You can do live migration. You can do anything you want with a Linux VM that you would do with a Microsoft VM. We're supporting the latest distributions, Red Hat, SUSE, OpenSUSE, CentOS, Ubuntu, Debian, Oracle Linux, and we're continuing to grow that as well. Now, this was such an important investment to Microsoft that we actually hired many of the top open source developers. They've joined Microsoft, and they're actually writing code that now gets checked into the Linux kernel. It goes through that same peer review process like all Linux code. And so our future distributions of Linux, they already contain things like our integration services built in. So there's no additional steps required to set this up. And we're going to continue to keep adding support for Linux as well. Now that really focuses on what we're really doing with our core compute capabilities. But the Hyper-V team's expertise with virtualization didn't narrow them down to just focus on compute, but it also gave them some improvements around our networking and our storage stack as well, using these same virtualization concepts, being able to define what was traditionally hardware-based components, now being able to define and manage them using software. And in this case, we're going to be speaking about software-defined networking, or SDN. As we look through our management stack, we have the same provisioning and operation needs. When we start to think about what is the brain, what is the control plane, we've introduced a new role into Windows Server known as the network controller. Finally, through our data plane, what we use to actually share the information, we do that using our virtual networks here. And once again, everything's built on our APIs. So what did we really focus on around network management? First of all, big thing was working around performance. What we found was that in many cases, the network and interface card, that could be a bottleneck to virtual machine performance. And the reason why is that all of those VMs running on a host, they need access to that actual network data. If they're copying information, sending information back and forth, in many cases, that network interface card could become a bottleneck if it's trying to take too much data for those virtual machines than it has capacity for. So this is another example where we've been working with our hardware manufacturers, trying to take advantage of new capabilities that they're building into their network cards to offload data. Whether it's offloading memory access, CPU access, graphic access, we've really tried to go and support all of these great innovations, including up to 40 gigabyte per second performance. We've also improved interoperability. Now, there's several different network virtualization protocols that exist in the market. Microsoft decided to support NVGRE, or Network Virtualization Generic Resource Encapsulation. However, other different types of data center providers have supported other protocols. Namely, VMware supports the VXLAN protocol. Many other third-party applications support OVSDB protocol. Now, what we've really done here is, instead of trying to basically have a protocol war, say that our protocol is better than another one, we decided to support interoperability here. And so our new network controller and System Center Virtual Machine Manager will be able to support other different types of networking protocols as well. So if you already have investments with software-defined networking using VXLAN or something else, you can now manage that using Microsoft technologies. Now, probably the biggest investment we've made with this release is introducing a new role into Windows Server, known as the network controller. The network controller is essentially going to be the brain for managing and operating all of our networking resources from a single centralized location. Now, this new role is going to be a new role as you actually install just like Hyper-V or file management through Windows Server, and it's going to just be the brain, the centralized operation. It will allow us to actually view all of our network devices and configure things, such as new different types of network function virtualization appliances, or NFVs. It allows us to manage our physical and virtual switches. It allows us to essentially do software-defined networking from that centralized location. We're going to make sure that we support all the industry standards as well, and pretty much everything's going to be a REST-based protocol. Monitoring is an area, though, where another example of Symon coming in, and I'm really trying to light up new capabilities and advantages. With Symon monitoring across your entire virtualization stack, you're also going to get good insight into the virtual networks as well. The final investment we made is another guest operating system management enhancement. Using this, we can actually allow our tenants that are using the guest operating system to get better visibility into host naming schemas so that they can correctly map their virtualized networking interfaces back to physical networking interfaces on the Hyper-V hosts. Now, as we continue to think about how we can provide software-defined networking, one of the key requirements is to try to eliminate physical networking devices. Things such as load balancers, firewalls, routers. And the reason why is anytime you add a physical device into the network path, it requires physical operation, physical connections, and physical setup. And this really hurts our ability to have this concept of a dynamic data center where we can rapidly make changes, scale up, and scale down based on changing environmental needs. Now, NFV, Network Function Virtualization, is essentially the broad terminology used for virtualized networking devices. So if you have a virtualized load balancer, that's an NFV of a load balancer. Now, what we've started to do with this release is we're providing a lot of these different NFVs in the box. So you're going to see a new distributed firewall. You're going to see a brand new software-based load balancer that can replace Windows Server network load balancing. You're going to see the ability to have Linux-based network components, different types of network management such as IPAM or DNS enhancements. And one that a lot of people have specifically asked for is network service chaining. Service chaining basically allows us to go and define the network traffic path across multiple different environments. So let's say that you have an end user connecting to your data center. First, you might want to send them through a VPN gateway, then through a firewall, then through a perimeter network, then an authentication server, then a specific router before you take them to the specific server they need access to. Using service chaining, we can essentially define within our network controller this traffic flow and enforce that people are getting connected and routed through the correct paths. We wanted to also centralize the control of this network management through System Center. So System Center gives us centralized control. We've worked with all of the main networking partners throughout the industry to make sure we understand their APIs and plug them in. So for example, if I say I want to go create a new network team between two network cards, we can now do that through System Center or through Windows Server using a single standard interface, regardless of who those underlying manufacturers are. We could go get information about our devices through System Center, change the performance, back things up, and we now have this new distributed firewall that allows us to have ACLs across all of our different properties. Finally, we're going to start to talk a little bit about how we've invested in virtualizing and managing our storage. So similarly with our compute and networking stacks, we have the same type of provision and operations tasks. The brain, or the controller plane, is managed by our storage cluster, our scale-out file server that goes and handles incoming and outgoing traffic. And then the data itself for our file servers, for our virtualized storage, that all runs on our file servers. We're using standard APIs throughout the industry, which means that our end users can use commodity hardware, JBOD disks, instead of having to invest in expensive traditional SANs. So as we think about virtualizing storage, our key investment areas were really to reduce the cost here. What we do is we can now take a group of spinning disks, JBODs, and we can pool them together using what we call storage spaces. Now, let's say I pull together eight disks, as you see in the diagram on the right. If these are 1 terabyte each, this is going to give me about 5 to 7 terabytes of pooled storage, depending on how many hot spares I use, different types of parity or mirroring. And what I can now do with this pool of, let's say, 6 terabytes, I can carve those disks up however I want. I could create a 3 terabyte virtual disk, or I could create 30 100 megabyte virtual disks. I have that control now that we've added this virtualized layer on top to go and carve out that storage exactly as I need for my different types of resources. The second key investment that we've made is include inbox storage tiering. And so in this case, I've got my spinning disks, my 8 orange disks, that are going to be maybe my medium speed storage. I'm then going to go and purchase a couple SSDs, some flash-based storage that's really fast, and I'm going to put that in my fast tier. Windows Server can now go and optimize how you access your data based on the frequency by automatically moving it between these different tiers. Similar to RAM inside a standard computer. So this means the data that you access frequently is going to live on your gold tier or your fast tier. Data less frequently on your slower tier, and we'll automatically move it for you. This means that your virtual machines get the fastest performance possible because they're running on storage that's optimized for their needs. We also wanted to make this resilient as well, so we've continued to make improvements to our REFS file system, our resilient file system. So you're going to see built-in things that hardware traditionally did, like journal scrubbing. That's now built directly into our file system itself, so there's no additional dependency on the hardware, yet you get better data integrity and better availability. One of the big enhancements we're making in our next version of Windows Server as well is supporting direct attached storage only clusters. In the past, when you created a failover cluster, you needed some type of shared storage, whether that's a SAN or a file server. What we can now do is actually take that local storage, that C drive or the D drive, across all of your cluster nodes, and we create a mirrored pool that replicates the data automatically. So you can now go and set up a 4-node failover cluster with 0 shared storage. We will go and handle all of that replication on the back end for you, which is further driving down costs and simplifying deployment options. Some other enhancements that we've made are improving our storage quality of service. Now, quality of service essentially allows us to set a minimum guaranteed amount of bandwidth to ensure that all of our VMs on a host are getting data, they're not being starved. At the same time, it also allows us to set a maximum amount of data so that one particular VM doesn't consume too much storage resources. And this allows our hosters to get better types of granularity and control and offer different service plans to tenants. But more importantly, it prevents one VM from starving other VMs on that same host. Now, we supported QoS for a couple of releases, but the major enhancement in our next version is being able to centrally monitor and apply policies across the entire data center so that all of your VMs and all of your virtual disks can use different types of policies as they need. And when new VMs are created or new disks are added to existing VMs, we can ensure that those same policies get applied as well. We continue to support all the latest high performance needs by introducing this type of tiered storage spaces as we met earlier. We have reduced storage utilization by including inbox deduplication that finds and eliminates duplicated data. We've made our virtual hard disks even more flexible, that they can not only be grown with no downtime, but they can also be shrunk with no downtime, allowing you to have more flexible storage management capabilities. All of this can again be managed through System Center. Probably one of the biggest enhancements that our customers are excited about with the next release is our inbox synchronous storage replication. Now, we started to support asynchronous storage replication in our last release with a technology known as Hyper-V Replica. What asynchronous storage replication does is it takes the changes at our first site, and then every 30 seconds, or 5 minutes, or 15 minutes, it will go replicate that to our secondary site as kind of an easy-to-use, in-the-box disaster recovery solution. So if our first site crashes, our data should be available at our second site. Now, the downside with asynchronous replication is there is a potential for data loss. If you're only replicating every 15 minutes, and it's been 10 minutes since the last replication, then you have a crash, you could potentially lose that 10 minutes of data. Now, the way to solve this is through a technology known as synchronous replication. And in this case, we write changes in our first site, it's immediately copied to the second site and acknowledged before it's committed in the first site. This then ensures that both of our sites have identical data and information. In the past, this was only supported by third-party replication providers, and these could be hardware block-level based replication providers like traditional storage OEMs, or this could be through software-based replication providers, people that actually copy at the file level. But we wanted to give our customers an end-to-end disaster recovery solution in this release. So we've now introduced our own in-box synchronous replication technology that's going to replicate at the volume level. We actually don't care if your clusters are identical, if your volumes are identical, if your disks or your file systems or data is identical. We're essentially taking a volume and copying all of that over for you. So this means that you're going to have zero data loss in the event of a disaster recovery solution. And we're making sure that we can support all of our newest technologies, scale-out file servers, SMB, deduplication, REFS, NTFS, you name it, it's going to be supported with the storage replication solution in our next version. Now, we wanted to really centralize this management of storage. So you're going to see us do this through our system center, where we're really going to have a single location to go provision this enterprise storage, manage it using a single interface, be able to monitor it, get insights into it, and to protect it. But once again, our insights are only going to be limited. And another example where Civision's Cloud Reporter is going to come in to give you insight into how that virtual machine's data is being used in your enterprise environment. Now, as I wrap things up before I turn it back over to Civision, I just want to summarize this and really remind you of Microsoft's strength here as being this unified cloud platform. We have 3 different clouds, our public cloud, your private cloud, our service provider cloud, yet you get to run your applications and virtual machines the same way across all of these different resources. And that is the Microsoft strength. Build it once, run it anywhere, on any cloud that you're going to use to meet your needs. Well, with that, I'm going to turn it back over to Stephen, and he's going to walk you through how Cloud Reporter can take your existing virtualization environment and enhance it, give you even better insights and understanding to really optimize it for this software-defined data center. Thank you.
Thank you very much, Simon. That was a lot of good information, and I know there are a lot of questions we're going to be answering. But yeah, as Simon said, we're just going to take a couple minutes and talk about Cloud Reporter. I was talking the other day to an IT administrator who had a massive Hyper-V infrastructure, and he said running Hyper-V is like driving a Formula One car with a blindfold on. You've got a lot of power at your hands, but you don't have as much visibility as you'd really like. So that's where Cloud Reporter comes into play. Actually, when Civision designed this product, it was originally custom designed for one of the largest financial service providers in the US. So we got their real-world experience, their real-world requirements, and we turned around and commercialized that so everyone else could take advantage of the product as well. So what we're going to do is we're just going to go through some of the scenarios and the use cases that Cloud Reporter could help you in your own Hyper-V environment as well. So just sliding on to the next slide, we're going to first talk about some of the task-based reports that we have in Cloud Reporter. So you've all heard of virtual machine sprawl, and especially in self-serve environments. You have people who will create a virtual machine, they'll use it for a while, and then they'll forget to turn it off. My analogy there is sort of like having children. They'll go into the room, they'll turn the lights on. When they're done, they'll never turn the lights off again, driving up the power bill. Hyper-V, you've got the same thing. All these virtual machines running, using up your resources, memory, sometimes some CPU, and they're not really doing anything. So one of the task-based reports in Cloud Reporter is to identify your idle virtual machines. So we'll go out, we'll scan through everything that you have, and we'll tell you the ones that aren't actually running or do anything, and give you the opportunity to power them off and free up those resources. Same sort of thing, especially against self-serve, if you have developers running amok on your environment. I'm a developer, I'm allowed to say that sort of thing. A lot of developers and organizations will spin up a virtual machine and then they'll start using it for critical workloads. And they don't tell anyone. And you're not able then to bring that virtual machine under the watchful eye System Center Operations Manager. It's just running this critical workload by itself, no one's watching it. So one of the other task-based reports in Cloud Reporter, we'll go through, we'll tell you every single virtual machine you have that's not being monitored by System Center Operations Manager. So then you can sort of do a risk analysis and say, are these virtual machines that we need to bring into monitoring as well? Moving to the next slide, Symon talked a little bit about the ability now to, on the fly to change some of the resource allocations within your virtual machines. And one of the things we do in Cloud Reporter is we recommend when it's time to actually do that. So we've got a whole bunch of right-sizing reports. So we'll look at virtual machines that are demanding more memory than you've actually made available to them, and then you have the opportunity to increase it. On the other side, we'll look at virtual machines and we'll tell you which ones are actually asking for less than you've allocated to them. And again, right on the fly, you can take that memory right out of them and use them for other virtual machines in your clusters. Same thing for processing power. We'll tell you which virtual machines we think, based on their current processor usage, could benefit from additional processors. Then moving along, we also have a bunch of reports that really give you visibility into what you have in your virtualized environment. So we'll tell you how many clusters you have, host, more importantly, how many virtual machines you have out there running, and what virtualization density you've achieved. And that's again a great metric to share with your CEO if you're trying, or the CFO as well, if you're trying to show what a great job you've done migrating to the private cloud and freeing up physical servers. As well, we're going to give you alerts when you're getting close to the threshold for some of your critical resources, like compute, like storage as well. So you can see here the sample report. We've got 2 clusters that can be facing memory exhaustion. All our reports in Cloud Reporter are click-throughable, so we click through right to that into the memory report, and we can see exactly when those clusters are going to run out. So we've got one that actually has free memory available, but is below the failover requirement. So we're going to notify that we're out of memory right now. Then we've got another machine that's going to run out of memory sometime in the future, or at least it was in the future when we made this slide. And of course, the final cluster is never going to run out because we're actually freeing up memory on a daily basis. Then moving on to the next slide, one of the big things we have in Cloud Reporter is capacity planning. So you can look at the historical usage of your resources like compute, network, and storage, and that can give you an idea of the future. But like they say in mutual funds, past performance is no real indication of what's going to happen. Sometimes there are events that you know are going to happen that can't be predicted. For example, you might be taking hosts out for maintenance. You might be launching a brand new application and you might expect a lot of load. You might be fortunate and you've gotten some extra budget and you're bringing new hosts and clusters online. So what Cloud Reporter lets you do is model out those scenarios. So we've got actually a user interface built right into System Center Operations Manager where you can model out all those scenarios, adding and removing hosts, adding and removing load. And as well, you can base it on the current loads that you have. So we give you ideas of what's small, medium load in your environment. And then you can say, I'm going to add more of that type of load. And then what we do is you run a scenario report. You can pick and choose all the different scenarios you configured, and we will tell you how your virtualized environment is going to respond under those different scenarios. This is a great report if you're sitting down with the CFO or the accounting people trying to negotiate for new hardware or new budget. You can tell them exactly under what scenarios you're going to be able to manage the resources and under which scenarios you're going to have a problem. So it's really using your past performance, enhancing it with what you know is going to happen in the future, and then coming out with a good plan for capacity planning. And then just moving on to the next slide, it's just a quick overview. of all the reports that we have in Cloud Reporter, I've just touched on a few of them. And again, this is a little overwhelming list, but they're all clickable, click through from one to the next. So you can go from the overview to memory resources, to look at the cluster, to look at the hosts in those clusters, to look at individual VMs. All just click right through, go from the problems right at the top, and see what the causes are right at the bottom. Just trying to make your life easier. How have we implemented Cloud Reporter? Just on the next slide, we talk a little bit that it's only thing you need to install is a set of Operations Manager management packs. Now we report on both Hyper-V and VMware, and we do it all through just management packs. You don't need to install external services, you don't need to install other applications elsewhere. It's just straight management packs. All of the reports will show you the VMware and the Hyper-V data at the same time in the same format. So the idea is that you no longer have to silo your virtualization efforts if you're running hybrid scenarios. You can see everything for your cloud in one place. Now, if you are in a siloed environment and the VMware and the Hyper-V people don't like to talk to each other, well, you can do that as well. And you can have the reports just look at Hyper-V or just look at VMware. And then our management packs are just giant sets of data collection rules. We talk to vCenter, we talk to your Hyper-V host, we write all that into the data warehouse, and then we'll let you run all these reports on it. Now, if you're interested in Hyper-V or VMware in Cloud Reporter, on the next slide we give you a little bit of information on how to contact us. If you'd like to actually try an evaluation version in your own environment, we'd happy to hear from you. Write to us at sales@civision.com. If you want to be even friendlier, write to us at partners@civision.com. We've actually got online demos of both our flagship product, Live Maps, and also Cloud Reporter as well, available at our website, civision.com. Follow us at Twitter, visit our website. We actually have a lot of webinars coming up in the future, a lot of white papers on Hyper-V and other technologies as well. And if you follow us on Twitter, you get advance notice of those. And we've got a lot of esteemed Microsoft employees and MVPs, just like Simon, that are online to be doing webinars and white papers for us in the future. So, with that said, I think it's time to get into some of the questions. So the first question for Simon is going back to the mixed mode clustering. So running different versions of the host. What's the minimum OS level that you need to have for mixed modes?
This mixed mode cluster, this is going to be a new technology introduced from this point on moving forward. And so this means that you're going to be able to have 2012 R2 plus vNext. In our next version, it's going to be vNext plus 1 plus vNext. So we're basically only going to allow you to do it between the current version and the next version.
Okay. Then we've got a couple questions around storage spaces. So the first one has the performance of storage spaces improved compared to 2012 R2.
Yes, it has. As you know, performance is something that we're constantly evaluating. You know, when we first release a product, we try to work with our hardware vendors as much as possible. But in many cases, we're still not at the point where we're getting that real-world feedback about how customers are using these technologies in different scenarios. So since our first release, the 2012 R2, and now our third release of storage spaces, we continue to make enhancements based on what our customers are doing, based on the latest storage enhancements as well. So yes, certainly something that we have found to be important. We've heavily invested in, so you should see a lot of performance improvements in this release. We have not yet actually finished the product, so it's too early for us to actually give a specific number and say, you know, we're 20% faster, because we're still continuing to improve performance as we work, you know, and continue to develop for this release.
Okay, another storage space questions. For storage spaces without shared storage, does the storage footprint on each cluster node need to be identical, or can you have different disk layouts on each host?
The way that we do replication is at the volume level. So what you would do with this direct attached storage only cluster is you would have to have 3 volumes that are the same. Now the underlying disk, we don't care, right? It could be, you know, a 30 terabyte disk, a 20 terabyte, a 10 terabyte disk. But what we really require for the cluster piece is to ensure that the volume is the same. And so whatever volume you pick within that disk, as long as they're consistent across all 3, that will be supported for this this DAS-only cluster.
Okay. Then I've got a question about the new networking virtualization. So you talked a bit about whole software-defined networking, and we don't need our physical hardware anymore. Is there room for the people who produce the physical hardware to come in and integrate new software-based solutions into your network control layer?
Absolutely. Great question. We have so many customers today that have already invested with these great networking vendors. And, it's not just like that networking equipment. It's also things to ensure that the network stays performant, ingress and egress monitoring, port mirroring, port forwarding. We want to make sure that we still integrate thoroughly with all of our partners. So absolutely. What we've done is we provided an extensible platform both within the core network controller within Windows Server, and then also with the advanced management using System Center, where our network hardware partners, they can go plug in so that we can use that network controller role and still deploy their load balancers or their firewalls. And likewise, through Virtual Machine Manager, they plug into that. We could go and create these distributed services. We can go manage the networks, regardless of whether it's a Microsoft technology or a third-party technology. So absolutely, we have been working closely with our networking ecosystem on that.
Okay. And I've got another, hopefully not too tough one to throw at you. The new file format for virtual machines, where you're now encrypting this file format. Apparently people did have use cases to manually edit it. So have you looked at those use cases and given them new APIs through PowerShell perhaps or VMM to accomplish what they were trying to do with the manual editing?
Great question. What we have done is we still provide full support through all of our different APIs to go edit that. So this means you could connect directly through APIs. You could use WMI. You could use PowerShell. You could use Hyper-V Manager, Failover Cluster Manager, or SCVMM. Any of those options you can go and use to go and make an adjustment to a VM or the VM's configuration file. What we have still prevented is from somebody just to open up something like Notepad and make the change in Notepad. And again, the reason why we had to lock this down was because when people were making those changes and that virtual machine failed over to a different node or it live migrated, many times those changes were not copied. And so the virtual machine wouldn't work and they would actually lose high availability. So kind of to answer the question, we're not going to give you the easy way just directly add it in that text file still, but we still open up all of our different programmatic interfaces to give you that kind of same capability. So instead of, having a script that directly edits the text file, your script would instead call WMI or it would call PowerShell or it would call one of those other interfaces to make that same change.
Okay. Question about WinRM. So Hyper-V hosts and Virtual Machine Manager make queries through WinRM. Have there been any performance improvements there?
Actually, the specific slide that I had earlier where we talked about different ways to go and actually connect to the virtual machines, that's actually where the big investment has been made. Hyper-V Manager now uses WinRM behind the scenes. So this means that it's faster, it's more performant, and gives you different options to connect. I'll be honest, performance tends to be one of the things that we get to last during our development cycle. So we're still working out a lot of the intricacies. So, similar to the other question about performance improvement with storage, I can't give you any specific numbers yet about how much faster it is, how much better it is. That's still kind of in progress. But yeah, that's definitely been one of the key investment areas. And you're going to notice that once you start to use the new Hyper-V Manager about how much quicker it is to turn on VMs, connect to them, start them up, things like that.
Talking about replication. So is there any native replication method used for site-to-site replication?
So that's a great question. What are our different options for replicating between two different sites? So we currently have one today. Actually, we have two today, and then we're going to be adding a new one in the next version. So today, you can work with an existing partner that does provide different types of replication. We have storage partners, the major storage vendors that provide block-level replication already. We have software partners that provide software-based replication, where they're actually replicating at the file or VM level. So that's one option today, work with partners. The second option today we have between multiple sites is using the Hyper-V replica technology, where we're replicating the virtual hard disk for a VM between these different sites. And we have similar capabilities as these partners, where you can do test replications, you can fail over, you can fail back. But again, the limitation with that inbox solution today
is that it is only asynchronous, which could potentially mean you have data loss. What we're going to be introducing in our next version and making available to all of our customers for free is that synchronous version of the replication, where we can copy any type of volume from one data center over to another data center. So today we have a couple different options, but this is an area that we're going to continue to invest for the multi-site recovery. Now, if you don't have a second data center, another option you can consider is a technology known as Azure Site Recovery. This was something that we announced over the summer that actually allows you to do failover of your virtual machines to one of Microsoft's data centers. So you can literally set up that replication and that failover from your primary data center up to a data center run by Microsoft Azure. So if you don't have that second DR site, you could take advantage of Microsoft sites located throughout the world for disaster recovery. If you want to learn more about that, do a quick search for Azure Site Recovery.
So a quick follow-up question. Will the synchronous be for the full VHD or for change blocks only?
So what we're going to be doing is we are doing change block tracking. So what we do when we do this replication is once you go and select the volume that you're going to replicate, we'll do a first initial replication. Now, you can send that over the wire, over the WAN if you want, or you have the ability to actually copy that data onto a local disk and physically mail that disk to your secondary site. So once you do that initial configuration and you sync that initial config, from that point on, we just do change tracking where we're just syncing the differentials or the deltas that are happening between our different sites. We also do compression when we're sending this data across. So our goal here is to optimize for speed and performance as we're still supporting this important disaster recovery scenario.
Okay, a question on networking. Will the new network controller role somehow replace the current physical NVGRE gateways?
Great question here. So just to add some context about the NVGRE gateway. Basically, the NVGRE gateway is a network function virtualization role. So, one of those physical things that we've now converted into a virtual machine that allows us to go and basically pass data between isolated virtual networks. Now, what we're going to be doing with the network controller is the network controller is going to be able to leverage that gateway. So think of the network controller as kind of the master brain, and the NVGRE gateway is one of the many functions that it will be able to manage. So in addition to be able to manage this NVGRE gateway, the network controller will also be able to manage your software load balancers. It'll be able to manage IP address policies. It'll be able to manage failover policies, updating those IP addresses. So to answer the question, the NVGRE role will still exist. It's going to be one of the components or one of the features of this new network controller functionality.
Okay, and for all the people that are asking about making the presentation available, it will be posted on our website, and we'll send an email out to all of you when it's available, probably a few days from now. Question, Symon, on user interfaces for a lot of these new features that are coming. From an admin point of view, is this going to be available in Hyper-V Manager and Virtual Machine Manager, in Windows Azure Pack? Where would I start to look to play with these new features?
So all of the features, unless I specifically mentioned it was coming with System Center, all of these features will be available in Windows Server. And in fact, they're all available today in the technical preview that you could go and download from the Eval Center. Now, I just switched and actually showed a couple of different resources on the screens here. The Evaluation Edition, the Eval Center, you can see as the second link in the list. But you can actually start experimenting and playing around with these features today. So we won't have any difference between the Standard Edition versus the Enterprise Edition. You'll be able to leverage a lot of these technologies and light them up through the Windows Azure Pack as we start to build extensions to connect it. Those aren't available today. But as far as all these basic features around the VM management, the storage management, the network management, we're providing these in the box with basic Windows Server. Really, the only kind of differentiating feature that you're going to see between the Standard Edition and the Data Center Edition is virtualization rights around the number of VMs that you can run in your environment. but taking advantage of all these other VM storage management features, we'll be offering them all in the box. Now, as far as how you expose them, are they going to be coming through Hyper-V Manager, through Failover Cluster Manager, through SCVMM? That's still something that we are working on. But one of the big areas of investment in this release is trying to build better consistency across these products, trying to eliminate the number of interfaces that our customers need to go to actually turn on and light up these features, whether they're running on a standalone host, in a cluster, managed through SCVMM. So still working on that, but that's definitely a big investment area to try to centralize the management of all of these new features.
Okay. One of the things Microsoft was talking about at TechEd Europe was their partnership with Dell. So you can get a whole private cloud dropped in your shipping dock, all with hardware, software, everything built out complete, and you just turn it on and start running. So I believe to support 2,000 virtual machines, the cost was about $2.5 million. So looking at $1,200 per virtual machine. So you were talking a lot about some of these features to increase density and so on. So do you see this next version of Hyper-V really dropping the cost of a virtual machine?
Oh, that's a great question. A lot of information in there. So to set some context on this question, at TechEd Europe, Microsoft made an announcement of a new partnership with Dell, producing what is now known as the Cloud Platform System, or CPS. And essentially, CPS is a hyper-converged system built between the Microsoft and the Dell engineering teams. And so what this means is you go and purchase a rack. You actually speak to Dell ahead of time, and you provide them with information such as, what's going to be the domain, what's the sizing, things like that. And they'll actually go and pre-configure those settings for you in the factory before they actually ship that physical hardware. Once the hardware arrives, it takes a couple hours to set up by the Dell engineer. All of the software and hardware is pre-configured, including redundant storage, redundant network connections. It includes clustering. It includes all of the Windows Server stack. It includes System Center to manage it, including automation tools for patching, monitoring, virtual machine provisioning, so all the System Center products. And then it even includes Azure Pack as well, which provides a self-service portal that goes and ties into all of these resources at the back end. So as the question alluded to, this literally is a full cloud in a box that you can purchase and go and connect into your data center. Now, as far as updating it, one of the things that we have worked on is ensuring that we have a smooth upgrade path. So what's going to happen is, as the next version of Windows Server comes out, you will be able to go through that rolling upgrade process that we talked about earlier, which means that one at a time you can go and upgrade each of the physical cluster nodes. We'll move the VMs around, and there'll be no downtime to the actual VMs or the applications, providing us the ability to go and upgrade that fabric, roll it out to the next release, and still maintain service availability for all of our different VMs. And so making sure that our customers have a great world-class experience with CPS is something that our engineering teams have invested in significantly over 18 months. So stay tuned. That's going to be something that we definitely support, as we want to make sure that our customers using CPS are getting advantage of the latest technologies. Now, back to the specific question, is it going to improve density? The idea should be yes. We're not going to be changing, at least at release, our initial scale requirements. So we still have 8,000 VMs per cluster, 1,000 VMs a node. So as of right now, that's not changing. But yes, the goal is to continue to go and reduce prices, provide better density, so that you should get a better cost per VM pricing over time.
Okay. Along the same lines, is there any thought to providing reference hardware specifications? So you've built this high-end system with Dell, but if I'm a small or medium business and I want to just build the server myself, where can I go to get the information on what hardware I should put in it to hit the highest, network throughput, disk throughput, and so on?
That's a great question. What we've done with the CPS system, this one provided by Dell, is we have provided the reference architecture around what type of hardware is being used. But the kind of the special sauce that's included with CPS is how we're actually working with Dell to pre-configure, pre-engineer, and actually optimize all of these VMs for their particular hardware. So taking advantage of things such as Dell's hardware offload, Dell's memory management, etc. So building that exact same system that you see in CPS, that's going to be kind of tough for an individual. But what we have done is we have provided a program known as the Private Cloud Fast Track. This is available if you just search Private Cloud Fast Track, it'll be the first link that comes up. But basically what that does is we've worked with a bunch of different hardware providers, all of the big ones like EMC, Dell, Fujitsu, NetApp, to provide reference architectures as well, where they say, here's what we recommend for you to go build your own cloud system. Here's the storage, here's the network, here's the compute, here's the power, here's the management capabilities. So if you go to this Private Cloud Fast Track program, you'll see a bunch of different reference architectures provided by all of the major hardware manufacturers so that you can go and build your own cloud system if you wish to.
Okay. Well, I think that brings us to the end of the questions. So I'd like to thank again Symon very, very much for leading this webinar for us today and telling us all about what's coming in next in Hyper-V. I'd like to thank all of the attendees for staying for this presentation. I hope you learned a lot from it. I know I definitely did. And again, invite you to visit us at civision.com or visit us on Twitter, twitter.com/civision. We have a lot of resources, white papers again as well on Hyper-V and the various things that you can do with it. And thank you again. I hope you have all have a great day.
Thanks for joining us, and thanks for having me.